Have you ever walked into work on a Monday morning, opened up your CI/CD pipeline, and just seen a sea of red? Yeah, you are not alone. Today, we're going to talk about how AI can tackle one of the most frustrating, time-consuming problems in all of software development: brittle test automation. Welcome to K11 Software Solutions' AI-powered test automation playlist. In this session, AI-augmented self-healing in legacy test automation frameworks, we examine practical approaches for introducing adaptive, self-healing capabilities into mature test suites. So, what does that actually mean? Well, the most important takeaway here is that we are not talking about throwing away years of work. We're talking about making what you already have a whole lot smarter.
You know the feeling, right? It's a story that's all too familiar for so many of us. You start your week, you're ready to build some cool new features, but instead, you're staring at a pipeline just full of failed tests. And the culprit? Something as tiny as a button ID change. And that's when the real fun begins, manually fixing every single one of those broken tests.
And look, this isn't just a feeling we have. The numbers back it up. It is a massive drain on resources. A staggering 40% of all QA time is spent purely on test maintenance. Let that sink in. That's almost half the team's effort just fixing things that used to work, instead of, building new tests or finding really critical bugs.
So this gets us right to the heart of the matter, what we call the brittle test problem. It's the reason our automation frameworks, the very things that are supposed to give us speed and confidence, often feel so fragile. So let's peel back the layers and see what's really going on here.
The root of all this pain, it usually comes down to small, seemingly harmless UI changes. A developer changes an ID, refactors some HTML structure, or maybe a dynamic ad pops up on the page. Now, to a human user, these changes are completely invisible, but to a traditional test script that's looking for something very specific, it's a dead end. And that just kicks off another frustrating cycle of maintenance.
Okay, so what is the solution? Well, the really good news is you don't have to throw out your entire framework and start from scratch. No. Instead, you can add what's called a healing layer. Think of it as an intelligent wrapper that you put around your existing tests to help them adapt to these small changes. Let's see how it works.
At its core, the basic self-healing process is really just a logical, rule-based fallback system. So first, instead of just relying on one single ID, you capture a whole list of potential ways to find an element: the ID, its name, class, XPath, you name it. Then, when the main one fails, the system just cycles through the backups, checks which one still points to the right thing, uses it for that test run, and, this is important, it logs what it did so you have a perfect record of the heal.
Now, a rule-based approach is a fantastic start. It really is. But it has a limit, right? What happens when the UI changes so much that all of your predefined locators fail? Well, this is where AI steps in. This is where we go from a simple checklist to a system that has true contextual understanding.
And this, right here, is the absolute game changer. Think of it this way. Rule-based healing is reactive. It can only use the backup plans you already gave it. But context-based AI healing, it's proactive. It doesn't need a pre-written list because it can actually look at the page, understand what an element is from a simple description, and then generate brand new, valid locators completely on the fly.
Here's what that looks like in the code. On the left, we're telling the machine exactly where to click based on our fragile attribute. One little change, and poof, it breaks. But on the right, you're not telling it how to find it, you're just telling it your intent. You're just saying, find the submit button. The AI handles the rest, figuring out the best way to locate that element in real time.
And this is the real power of AI. It uses natural language processing, so it can actually understand a plain English description, like the blue rounded button, and then generate all the technical locators it needs. We're talking new CSS selectors, robust XPaths, and it even validates its own suggestions against the live page to make sure it's right before letting the test continue. It's pretty incredible.
Okay, this all sounds amazing, I know. But you're probably sitting there thinking, how on earth do I actually plug this into my existing, maybe kinda old, framework? Let's walk through the practical steps. It's more achievable than you think.
The architecture really breaks down into 5 key steps. First, you'll create an adapter layer to wrap your element finders. This becomes the one spot that can trigger a heal. Next, you build a repository to store your locators and historical data. Then, you integrate a local large language model, maybe a fine-tuned open-source model, to be the brains of the operation. After that, you'll need a decision engine to rank the AI's suggestions. And finally, you implement what's called controlled persistence, which lets the system heal in real time while a human still gets to approve any permanent changes to the code.
And here is probably the best part. You don't have to switch everything over all at once.
The recommended approach is called hybrid mode, and it's a fantastic strategy. You just let your normal locators run first. If and only if they fail, the AI healer kicks in as a fallback. This gives you the best of both worlds, the stability of your old code with the new resilience of AI. It makes the whole transition super smooth and totally risk-free.
So, what does this all really mean in the real world? What are the tangible benefits, the bottom line results? And more importantly, how can you actually get started with these ideas today? Let's take a look.
Let's go back to that Monday morning nightmare we started with. With traditional tests, a simple ID change means a failed build and hours of your day gone. But with AI self-healing, the system just adapts to the change. The test passes, and honestly, you might not even know there was a problem to begin with. The result? 0 manual fixes. You get 4 hours of your life back.
And this isn't just a win for engineers and QA, it's a win for the entire organization. For engineering leaders, it means less technical debt and faster releases. For product teams, it means faster feedback loops and way more reliability. And for the organization as a whole, we're talking lower operating costs and a test suite that's actually ready for the future.
So, to wrap it all up, if you're going to remember just a few things from our session today, make it these. 1. Start small, focus on your most critical user flows first. 2. Use that hybrid mode for a safe and easy transition. 3. And this one is a big cultural shift. Start training your team to think in terms of describing elements, not just finding their IDs. And finally, measure everything. Prove the value and plan for how you're going to scale.
Now, if you're ready to dive in and get your hands dirty, K11 Software Solutions has some really great open-source resources for you. You can find their entire AI testing framework up on GitHub, and you can even run a live demo of the self-healing workflow with a simple Maven command. It's a fantastic way to see this technology in action for yourself.
And with that, we've reached the end of our explainer. As you think about everything we've covered, I'll just leave you with this one question. What's the single biggest challenge you face with your current test automation framework? And is it possible that an intelligent healing layer could be the solution you've been looking for?